questions 11 through 20 on the 2011 grade 10 AMC 10B. There are 52 people in a room. What is the largest value of n such that the statement, at least n people in this room have birthdays falling in the same month, is always true? Well, as you know, there are 12 months in a year. So if we were to take the 52 people and distribute them equally among the 4 months, 4 born in January, 4 born in February, like that, then each of them obviously would have 4. But when you do that, it only equals 48, right? Because 12 times 4 is 48. But there's 52 people. So there's 4 additional people. Let's distribute those additional 4 people evenly. So 1 here, 1 here, 1 here, 1 here. That means that this actually becomes 5, 5, 5, and the remaining are all 4. So now let's look at the statement. At least n people in this room have birthdays falling in the same month. Is that true in this scenario for n equals 4? Yeah. Is it true for n equals 5? Yes. So they're asking for the largest value of n. So among 4 and 5, the largest is 5. Now, you might think, okay, well, that's just this scenario. What if you have another scenario? In any other scenario, the distribution will be such that you won't be able to get a value that is always going to be true. That is a very important part of that question, always true. So number 11, the answer is D. Kiko walks once around a track at exactly the same constant speed every day. The sides of the track are straight and the ends are semicircles. The track has a width of 6 meters, and it takes her 36 seconds longer to walk around the outside edge of the track than around the inside edge. What is Kiko's speed in meters per second? Well, let's break this down. Approximately here is where those straightaways end and the curves begin. And they don't actually give you a lot of information here. So I think that means that certain things are going to cancel out. We are not told anything about the distances except that 6 there. So what I'm going to do is just label them. From here to here, since that is the radius of a semicircle, I'll just call it R. And of course, this is going to be R. And this is R, like that. From here to here, they don't give me anything, so I'll just call that X. And this, of course, they give me is 6. So those are 6's. And that's it. All right, so we're going to use the formula speed is equal to distance over time. Now, in the inside, so when we are walking just on the inside right there, like that, the total path will be equal to 2x, right, the 2 straightaways, plus the circumference of an entire circle, because it's 2 semicircles. And the circumference of an entire circle is pi times diameter, or pi times 2r. All right? In a very similar way, on the outside, that path, which of course is going to be like this all the way around, that one, the straightaways are here and here, so that's 2x. And then let's see here, we've got 2 larger semicircles there and there, so that's 1 full circumference. So again, that's pi times 2 times the radius. But this time, the radius is not r, the radius is from there to there, which is r plus 6. All right, so that takes care of the distances. And then now we just have to take into consideration this 36. That means that the time here, which is of course, according to this formula, distance over speed, and the time here can be compared. This is obviously going to be, well, let's just call it d2 over speed. The speed is the same. The distances are different. This is d1, and this is d2. that one. Well, this one, T2, is compared to T1 in the following way: 36 seconds longer to walk around the outside. So that means T2 is T1 plus 36. So it's T1 plus 36. And that is equal to D2 over S. And T1 is D1 over S. Well, D1 is just this. So it's 2x plus pi 2r over S. All right. Now we can move forward. T1 plus 36 is equal to D2 over S. Well, D2 is this guy right up here. And that is 2x plus, let's multiply it out, to pi 2r plus 12 pi. And that's all over S. But I'm going to break it up like this. And the reason is because when you break it up like this part is identical to this part. So I can just substitute T1 for that. And that allows me to cancel out the T's, which is very good. And when you do, all you're left with is 36 is equal to 12 pi over S. And cross multiply and you get S is equal to 12 pi over 36. And that means that it is equal to pi over 3. So number 12, the answer is A. Two real numbers are selected independently and at random from the interval minus 20 to 10. What is the probability that the product of those numbers is greater than 0? Now, we have all these real numbers. They're not necessarily integers, which is interesting. It could be anything from minus 20 all the way until positive 10. And obviously, 0 will be somewhere here, right? So the negative numbers comprise 20 over 30 of the line segment, and the positive numbers comprise 10 over 30 of that distance of the line segment. Now, if you take two numbers at random, their product will be greater than 0 in the following scenarios. Two numbers have a product that's positive if they are both positive. Of course, positive times a positive equals positive. Or if they are both negative, then that would also result in a positive. So we want the probability of these two scenarios, and then we can add them. The first scenario, this one right here, to get a positive number, the probability of that is 10 over 30, which is 1/3 basically. That's for the first number, but we're choosing two numbers. And to get the second number that is a positive, again, it's the same, 1 over 3. And this question is a little bit unclear because that means that those two numbers could be the same? I think so. Well, that 1/3 times 1/3 is 1/9. So that takes care of this first scenario. Now we look at the second scenario where you have two negatives. The probability of getting a negative number is 20 over 30, which is 2/3. And then the probability of choosing a negative number for the second number is again 2/3. And that, of course, is 4 over 9. So we have to add these two to get the total probability, and that is, of course, 5 over 9. So number 13, the answer is D. A rectangular parking lot has a diagonal of 25 and an area of 168. In meters, what is the perimeter of the parking lot? So we have this rectangular parking lot, and width, length, they want us to find the perimeter, which is, of course, 2 times the length plus the width. Now we use a little bit of algebra here. L plus W squared. If you were to do that, of course, you would get L squared plus 2LW plus W squared. Then we take into consideration the fact that they gave us some very important information. They gave us that the diagonal is 25. Now, using Pythagoras, L squared plus W squared is 25 squared. So this L squared plus this W squared, if you were to group them together like this, and then just put that 2LW, this is 25 squared. Okay? And then they give you another piece of very important information, that the area is 168. So that means length times W is 168. So this LW is 168, this one right here. So there we go. We can, using just some basic algebra, figure out what is L plus W. Well, it's 625. 2 times 168 is what? 336. So that means this is going to be 961 for L plus W, all squared. Take the square root and you get L plus W is equal to 31. So now we want the perimeter. Perimeter is 2 times L plus W. That means it will be 2 times 31, which is 62. So number 14, the answer is C. Let at denote the averaged width operation. A at B is A plus B over 2. Which of the following distributive laws holds for all numbers x, y, z? Okay. Well, to avoid making things abstract, let's just use some numbers. We can use anything really, but how about A, or x rather, is 6, y is 8, and z is 10. That should be good enough. So let's work with these one by one. Let's start with 1. 1, that would mean 6 at 8 plus 10. Let's look at what that is equal to. That's going to be 6 at 18, which is the average, so 6 plus 18 divided by 2, and that's 24 divided by 2, which is 12. Now let's look at the right side of 1, and that is going to be x at y, which is 6 plus 8 divided by 2, plus x at z, which is 6 plus 10 divided by 2, which is 14 divided by 2, which is 7, 16 divided by 2, which is 8, and that's 15. So 12 obviously doesn't equal 15, so this is gone. So that means A and D are out in terms of the answer choices. So let's see now, continuing. For the second one, we've got x plus y at z, so we have 6 plus 8 at 10 for that left side. So that's 6 plus 8 plus 10 over 2, and that is 6 plus 9, which is 15. And then on this side here, it's going to be x plus y, which is 14 at x plus z, which is 16. So that means it's 14 plus 16 divided by 2, and that is 15. So these two match. So that means 2 is true. Okay? So 2 is true. So 3 only cannot be true because 2 is true. So now we're down to just B and E. All right, I think I can do it in the same screen here. Now let's look at number 3. X at y at z. Okay? So that means you have 6 at y at z is 8 plus 10 divided by 2. So that's 6 at 9, and that's just going to be 6 plus 9 divided by 2, which is 7.5. And then finally, let's look at that guy. That is going to be x at y. So x at y is 6 plus 8 over 2. And then x at z is 6 plus 10 over 2. So that looks like 7 at 8, and that's 7 plus 8 over 2, which is 7.5. So this is the same as that. So 3 is true. So that means 2 and 3 are true for number 15. So therefore the answer is E. A dartboard is a regular octagon divided into regions as shown. Suppose that a dart thrown at the board is equally likely to land anywhere on the board. What is the probability that the darts land within the center square? So we obviously have to figure out the area of the entire region and then figure out the area of the square in the middle. So this is a regular octagon. That means all the sides have the same length. So x, x, and so on. And if you continue our labeling, that's x, and so are those two. But these are not going to be x, right? Those we don't know. So I'll call those y, all those guys. So first let's figure out our equation, and then we'll try to figure out the values for x and y if it is necessary. So our probability is basically the probability of landing in the middle, which is that square, which will be x squared in terms of its area. Then we have to divide by the probability of the entire octagon. Well, the entire octagon looks like first that square, x squared, plus 4 of these rectangles, this one, this one, this one, and this one. They're all the same in terms of their areas. They're all equal to x times y. And then 4 of these triangles, they're all the same. And they all have an area of 1/2 y times y. So simplifying a little bit, this becomes x squared plus 4xy plus 2y squared. All right. So now we have to figure out a relationship between x and y, and that can be easily done with Pythagoras with one of those triangles. Y squared plus y squared is equal to x squared. So 2y squared is x squared. So I can now, instead of putting this 2y squared, I can put just x squared. And then I can also substitute y for x or x for y. If I take the square root of both sides, this will become root 2y is equal to x, and therefore y is equal to x over root 2. So this can become plus 4x, and instead of y, x over root 2. So this becomes x squared over x squared, 2x squared, right? This one and this one, adding those together, plus 4 over root 2 x squared. Okay, so far so good. So now we have to change this into some sort of form that looks like one of these. The good news is all the x squareds cancel. So you're just left with 1 over 2 plus 4 over root 2. And at this point, this is just, trying to make this answer look like one of the answer choices. Okay, well, let's add the fraction, root 2. So that's going to give me 1 over 2 root 2 plus 4 over root 2. Invert and multiply, and you get root 2 over 2 root 2 plus 4. And we're going to have to rationalize the denominator here. So 2 root 2 minus 4, 2 root 2 minus 4. So this becomes 2 times 2, which is 4, minus 4 root 2. On the denominator, it becomes 4 times 2, which is 8, minus 16. And that is going to be 4 minus 4 root 2 over negative 8. And if you divide top and bottom by negative 4, you will get root 2 minus 1 over 2. Root 2 minus 1 over 2. And that is A for number 16. In the given circle, the diameter EB is parallel to DC, and AB is parallel to ED. The angles AEB and ABE are in the ratio 4 to 5. What is the degree measure of angle BCD? EB is parallel to DC. So this angle, or line I should say, is parallel to that one. And they also tell me that AB is parallel to ED. So this is parallel to ED right here. And then this angle, let's say, is x and that's y, they tell me that those two angles are in the ratio 4 to 5. Well, this is a diameter. So that means that this angle must be 90 degrees. That's a rule. Any angle made within a semicircle will be 90 like that. So that means x plus y is 90. So we can easily just figure this out through ratios. This is basically going to be that x plus 5x over 4 is 90. So that means that's 9x is equal to 360, so x is equal to 40. And that means y is equal to 50. Now we have to take into consideration the fact that we have parallel lines that will help us. So this, if you were to draw this z pattern, this angle is the same as that angle, right? So if this is 50, then that means that this is 50 right here, this angle in here. Okay, so now which angle do they want us to figure out? It's BCD. And where is BCD? It's right here. And there's a couple ways. There's several ways to approach this question at this point. The first way is to recognize that this right here is a cyclic quadrilateral, because all four vertices are on a circle. And the property in a cyclic quadrilateral is that opposite angles add up to 180. So this angle and this angle add up to 180. So that means that that angle BCD and 50 add up to 180 degrees. So that means BCD is equal to 130. And like I said, there's other ways of doing this question. Whatever way you're comfortable with is perfectly fine, as long as you arrive at the correct answer. And number 17, therefore, the answer is C. Rectangle ABCD has AB equal to 6 and BC equal to 3. Point M is chosen on side AB, so that angle AMD is equal to angle CMD. What is the degree measure of angle AMD? All right, let's talk about this. So we've got some triangle, right? And they've given us some dimensions. It's 6 and 3. And they're saying that there's some M along this ABCD, in particular on AB. So I don't know where that M is, so let's just say it's here. Right there. And then they're saying that when you draw lines, say from D to M, and then M all the way to C, then the angles AMD, which would be right here, call that theta, is equal to CMD. So this is also theta. Okay? And then they want you to figure out AMD. So I guess, what is theta? All right, so the first thing, of course, is let's take advantage of the fact that this is a rectangle. So these are, of course, parallel lines. This is parallel to that, right? It's a rectangle. So from the Z pattern that I just drew, this angle also has to be theta. This is the same as that, if those lines are parallel. So now in this triangle CDM, I hope you can notice, if those two have the same angles, this and this, that must be an isosceles triangle. So that means this is equal to that. Well, DC is 6, so that means CM must also be 6. And therefore, now I can figure out the length of MB using Pythagoras. So MB all squared plus 3 squared is 6 squared. So that means MB squared is going to be 36 minus 9, and that's 27. So MB will be the square root of 27, and square root of 27 is 3 root 3? Yeah. Okay, let's write that there, 3 root 3. Now the good news is, I hope you can see in this triangle, BCM, that the ratio of the sides are 1, 2, and root 3. And since those ratios happen when it's a 30, 60, 90 triangle. That's a 30, 60, 90 triangle. And this is, in particular, this is 30 degrees right here, and this is 60 degrees. So now we can solve, because the sum of all the angles about a line are equal to 180. So that means 2 theta plus 30 is equal to 180. Therefore, 2 theta is equal to 150. And therefore, theta is equal to 75. So number 18, the answer is E. What is the product of all the roots of the equation 5 absolute value of x plus 8 under the square root is equal to x squared minus 16 under the square root? In this equation, keep in mind that anything under the square root sign has to be greater than 0, right? Otherwise, it's undefined. So x squared minus 16 must be greater than or equal to 0. And that's true if x squared is greater than or equal to 16. So that means x is either greater than or equal to 4, or x is less than or equal to negative 4. So for each of these scenarios, we will figure out what is the root of that. If x is greater than 4, then this equation basically becomes 5x plus 8 under the square root sign is equal to x squared minus 16 under the square root sign. So that's for this first scenario. X is greater than 4. Take the square root of both sides and get 5x plus 8 is equal to x squared minus 16. And then put everything on one side. X squared minus 5x minus 24. And I believe this will factor x, 8, 3, negative, positive. So that means, according to this, x is 8 or negative 3. But our condition is that x has to be greater than or equal to 4. So we can reject the negative 3 and just use the x equals positive 8. So that's our first root. The next scenario is when x is less than or equal to negative 4. That makes this original equation equal to 5. This time we have to put negative x plus 8. And that remains x squared minus 16. Square both sides, and you get minus 5x plus 8 is equal to x squared minus 16. Put everything on one side, and you get x squared plus 5x minus 24. And I believe that factors x, 8, 3, positive, negative. So x is either equal to negative 8 or positive 3. But in this particular scenario was calculated for x less than negative 4, so we can reject the 3 and only keep the negative 8. So there we go. We got x equals positive 8 and x equals negative 8. Those are the two roots. And they want the product of those two roots. So the product obviously would be x times 8 times negative 8. And that is negative 64. So number 19, the answer is A. Rhombus ABCD has side length 2 and angle B is 120. Region R consists of all points inside the rhombus that are closer to the vertex B than any of the other three vertices. What is the area of that region R? So first let's draw a rhombus, and remember, rhombus, all four sides are equal, and let's just draw it in a way that it looks somewhat believable. So that's pretty good. And they don't give us much. They only tell us that B is 120 degrees. So this angle is 120. All right, we have to work with this. So first, let's talk about the region R. Where is that region R going to be? Okay, well, we want any point to be closer to B. So if we draw a diagonal from A to C, any point in here is obviously closer to D than it is to B. Therefore, we know for sure that it's got to be in this area, somewhere in here. But that doesn't give us the full story. What if it's here? it's obviously closer to C. Or what if it's here? It's obviously closer to A. So in addition to being on this side of that diagonal, the point also has to be as follows. Draw a midpoint from A to B, right there. We'll call that E, let's say. And draw a midpoint from C to B, so right here, and call that H. And then draw perpendiculars, so like this, so that's a perpendicular, and like this, that's a perpendicular. This is now the region where anytime you put a point, it will be closer to B than any other vertice. It won't be closer to A or C. If you put it here, obviously it'll be closer to A. If you put a point there, it'll be closer to C. So we are interested in that region. In that region, we can just call it R. Well, they have called it R. This region right here. That one. So we have to now figure out the area of that region. Okay. So far, I hope that makes sense. Now, how do we figure out the area? Well, there's a few ways. The first thing, of course, is I'd like to figure out actually the area of the full rhombus. And the area of a full rhombus can be figured out by diagonals. So if I write those diagonals, the area is D1, the first diagonal, times D2 divided by 2. Okay? And let's just label this. Let's get rid of this x here. Let's label the distance from here to here anything you want. We'll just call it A. And the distance from there to there, I'll call it B. And they told me that the angle is 120. So when I chopped it in half, this whole thing was 120. And since this is a rhombus, this is also going to be 120, right? But when you chop it in half, it becomes 60 and 60. Like that. Now, diagonals of a rhombus are always perpendicular, so that's 90 degrees. So therefore, this angle must be 60. And we are told in the question that the side length is 2. So the good news is that knowing that the 30, 60, 90 triangle gives us ratios, right? You all know that. We've done that a million times. 2, 1, and root 3 in terms of the ratio of the sides of a 30, 60, 90 triangle. That means very conveniently our values end up to be B is root 3 and A is 1. So our diagonals, D1 is basically 2A, which is 2, and D2 is 2B, which is 2 root 3, all divided by 2. So that area basically is 2 root 3. And that is the area, the full area of the rhombus. Now we have to figure out just this region right here. And you do that as follows. You will take the area of the rhombus. So R is what we have to figure out. That's going to be the full area, which is 2 root 3. First divided by 2, and that will just give you that much. And then subtract these two triangles. Now, it's not exactly drawn to scale, but this triangle will be the exact same as that triangle. So it's 2 times 1/2 base times height. Now, to get this base and to get this height, again, we're going to use a 30, 60, 90 triangle. And I'll just draw that triangle again over here, just to avoid making the diagram messy. So what I did is I took this triangle right here and then just drew it here. So, for example, this is A and this is E. And this is a right angle, and this is 30 degrees, and this is 60 degrees. And from here to here is 2, because the side length is 2, and since E was the midpoint, AE is 1. So now I can figure out this, I can just call it H. H over 1 in terms of my ratios will be the same as 1 over root 3. So there we go. We have everything we need to figure that out now. So we got 1/2 base. The base is 1, and the height is 1 over root 3. All right, so this becomes root 3. And this looks like 1 over root 3. Rationalize the denominator, and that gives me root 3 minus root 3 over 3. And this will be 3 over 3. So that's just 2 root 3 over 3. 2 root 3 over 3 for number 20 is C.